Okay, well, we've hooked up a Fluke distribution amplifier. This is a Model 203A made by Fluke. It's that unit right here ahead of us. And as you can see, the power's on. We're registering something on the meter over there. You're wondering what. And we see that we've got this knob here with 12 positions as a level check. And then there's a power supply, and then there's 3 preamps. Um, what this does is it'll take 3 different frequencies of input. It'll take 100 kilohertz from a 100 kilohertz oscillator, a 1 megahertz oscillator, it'll take that signal, and it'll take a 10 megahertz oscillator. So you can have 3 different OCXOs on your bench and provide those 3 signals into the back of this unit, and it provides you 3 different controls to control the gain that this unit will provide to those signals coming in. And then each one of those 3 signals has 4 outputs available. So channels 1 through 4 are for the 100 kilohertz, channel 5 through 8 are for the 1 megahertz, and channel 9 through 12 are for the 10 megahertz. And there is a power supply check here. We're getting 5 volts out of the power supply, which is what we want. And then here's channel 12. We've got 1 volt of output under load because I'm feeding that signal out to something. Here's channel 11. That's a 10 megahertz signal with a little over 1 volt. Channel 10 is a 10 megahertz signal, a little over a volt, and the same with 9. So all 3 of those have an output of 10 megahertz, and they've been adjusted. Channels 1 through 8, there's no signal coming in right now, so there's nothing there registering. Then on top of the unit, you'll see that we've got 10 megahertz, 1 megahertz, and 0.1 megahertz. There's 4 adjustment slots on the top for each one of those frequencies, and that allows you to adjust each channel so that you get the voltage that you want being provided on the output. So I've adjusted it for roughly a volt on each output. And what we've done is we've connected the Philips that has the 10 megahertz OCXO in it that I'm very happy with. And we've taken the output from the rear of the unit and we fed it into the input, the 10 megahertz input on this Fluke distribution amplifier, and that gives us 4 outputs. One of which right now, channel 12, is running up to another counter. And that other counter right now is reading 10 megahertz to 3 zeros. And we can increase the time on that to see if we can pick up an additional count. We'll let that go for a minute while it's doing that. And at the same time, I'm feeding this is a 1 megahertz, no, I'm sorry, feeding a 10 megahertz signal out of this PTS right back into the channel A on this Philips, just to prove that the Philips is still capable of reading the frequency, which, let's make it a different frequency so there's 12 megahertz. So it's reading 12 megahertz at the same time that it's putting out a signal to the distribution amplifier to be used right now by another piece of equipment up here. So yes, you can run your bench with a distribution amplifier and using this OCXO that's in this counter, which is good. I mean, it's a very good OCXO. It's registering very closely to my my rubidium standard right now, and I haven't touched this thing in months, so I'm quite amazed by that. And there's a lot of benefits to running your bench off of a common OCXO. Any generator that has a 10 megahertz input on the back of it, meaning that It's got a counting circuit system inside that's generating 10 megahertz internally, and you can switch it to external. Then you run that generator off of the same OCXO. What comes out of that generator is going to be the same thing that you read on your counter, like within whatever the characteristics of the device are. Like in this case, the generator would put out within a hertz, and the counter would read within a hertz. And it makes everything come together beautifully. So recommend that to you highly, and I'm just demonstrating that this unit can be used as your master bench oscillator if you wanted to. All right.